This is the video notes that go along with our notes, graph in standard form using the intercepts. So we have 3 vocabulary words we need to define first. The first one is standard form. This means AX plus BY equals C. A, B, and C are numbers. Typically, A is a natural number. B and C are integers if you are in true standard form, okay? Now, your y-intercept is going to be the point where the line crosses the y-axis. Now, what's important about this is that that point is always going to have an x value of 0. We call the y value in that point lowercase b, okay? Now, x-intercept is the point where the line crosses the x-axis. Now, its ordered pair is always going to have some number in the x and a 0 for the y value, okay? There is no symbol for the x-intercept like B is for the y. Okay, so what we're going to do in this is we're going to look at equations that are in standard form, like example 1 and 2. And we're going to graph these, but instead of using our slope and our y-intercept like we had before, we're just going to use our x and y intercepts, okay? So let's go back and talk about this a minute. If I'm looking for my x-intercept, what I know is that y has to be 0, okay? Y will have to be 0. So what I'm going to do is take my equation up here and I'm going to replace the y with a 0. Okay, so what I'm going to have is 3x plus 4 times 0 equal to 12. Just like that. Now, we know that 4 times 0 is 0, so what I really have right here is 3x equal to 12, and that means x has got to equal to 4. So that means my x-intercept is positive 4. So I know it's going to cross the x-axis right there at 4. Now, I'm going to repeat this process to find my y-intercept. But to find the y-intercept, what we know is that the x value is 0. Okay, so I'm going to just repeat that right here. So I'm going to let x be 0. So I'm going to have 3 times 0 plus 4y equal to 12. Well, 3 times 0 is just 0. So what I really have is 4y equal to 12. And that means I've got y equal to 3. So that means it's going to cross the y-axis at 3. And I'm just going to grab me a ruler or a straight edge, and I'm going to graph that point, just like that. Now, y'all, take a look. That 0 thing makes sense because my x-intercept is where I'm going to cross on my x-axis. Well, what is one of the characteristics about every point on the x-axis? Every point has a y value of 0. Look right here. 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0. Every point on the x-axis, the y coordinate is 0. It's just a complete opposite right here. If I'm on my y-axis, x is 0, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. They all have a 0 in for your x coordinate. Okay? Now, stop and pause and copy this down. We've just graphed a line using its x and y intercept. Now, the only thing with number 2 is I have some minuses and negatives. Okay? Now, I want to find my x-intercept first, so I know y is 0. Now, I'm going to slide this down for just a second. What did we notice when y was 0? That whole y term just disappeared, and I was left with my x term and my constant. So I'm going to just take a little bit of a shortcut here. Knowing that y is nothing, I'm going to take out my y. Okay, so I'm left with 8x equals negative 16, which means x is equal to negative 2. So my my x-intercept is at negative 2 right there. Now, I can pull the same little trick with my y-intercept. For the y-intercept, I know x is 0. So I can let the x coordinate just disappear. So I've got, or the x terms, so I've got negative 4y equal to negative 16. So negative 4y equal to negative 16, which means y is equal to 4. That means I'm crossing at 4 up here. That little rule that says you only need 2 points to draw a line. Here we go, our 2 points, our line, and I'm making sure I put arrows. Okay, go ahead and pause and copy, and then we'll go to example 3 and 4. Now, example 3 and 4 are the horizontal and vertical lines, okay? But I do want to talk about those in terms of intercepts again. Number 3 right here, y equals 3. Well, Hoyvux tells me with the y equals 3, this is a Hoy. That means it is a horizontal. It tells me my y-intercept is 3. So I'm going to cross the y-axis at 3 right here. And when I draw my horizontal line, I'm noticing something. That line is running parallel to the x-axis, which means there is no x-intercept because it's never going to cross. Okay? So a little note. There is no x-intercept except for, because there's an exception to the rule. If I have the line y equals 0, if I have the line y equals 0, that means my line is going to be right here on the y-axis. I'm sorry, the line y equals 0, let me say that correctly, is actually the same as the x-axis, which means every point on the x-axis is an x-intercept. Okay? So every horizontal line has only a y-intercept, no x-intercept, unless your horizontal line actually is y equals 0, which is the x-axis. Then it does have an x-intercept. Every point on the axis is an x-intercept. Okay? Now, let's look at number 4, x equals 3. Well, again, if I go back to Hoybucks, that tells me that this is going to be a vertical line, and my x-intercept is 3. So I'm going to go to 3 right here on the x-axis. And I'm going to draw a vertical line right here, just like that. Now, what do I notice? This is like the other one, except for I do have an x-intercept, but I don't have a y. Okay? So, make it a little star right here. No y-intercept unless my line is x equals 0. Because if I talk about the line at x equals 0, that means it's right here on the y-axis. So that means every point on that line is an intercept. Again, y'all have always heard that saying, to every rule there is an exception. The fact that vertical and horizontal lines only have one intercept is true unless it's y equals 0 and x equals 0. Now, go ahead and get these copied into your notes and go to Canvas and work on your assignment.